My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 653. In this lecture, I will continue my discussion on code example Imdb sentiment classification. This lecture is continuation of my previous lecture, that is lecture number 652. Just go through my previous lecture, all these concepts. I am borrowing the slides from my previous lecture. Just what I did here, I typed this particular sentence, padding for text sequence. I am getting this output. I request all of you to just read this particular statement. It explains the importance of padding, which we discussed in our previous lecture. All these slides are from my previous lecture. Now let's build the model. That's what it says, create the model. Very simple. Let's build the model. My model is this. I'm creating a variable called embedding underscore vector underscore length equal to 32 of size 32. It's a sequential model, and first layer I'm adding is called, what is this first layer I'm adding? First layer I'm adding is called embedding layer. You might wonder, what is embedding layer? Let's go to this documentation for embedding layer. This is the documentation for embedding layer. Just type embedding layer Keras. Just type in Google embedding layer in Keras. You will get this particular documentation. You will get nice documentation what an embedding layer does, isn't it? Just see, it takes indices like 420. What is the purpose of this particular embedding layer? It takes indices like this. Just see 420. Just see here also I am saying, yes, it takes indices like this and returns vectors. It returns vector. Just see, it is a vector. This is also a vector. It returns vector for you. And embedding layers used a lot in your natural language processing tasks, isn't it? The way the architecture looks is this. First, I have an embedding layer. Just see, I have an embedding layer. Each what I am doing, this is let me assume this is an embedding layer. Each of my words, I'm taking only 5000 words. Let me assume there are 5000 words. Each of my words are represented as 500 dimensional vector, one hot encoding vector, isn't it? This is, what is this 500 dimensional vector? We know how to represent one hot encoding vector, which we discussed in NLP. I can represent each of my words like 5000 dimensional vector. This embedding layer, just see, what is this embedding layer? It's like word to vec, because word to vec is one example of an embedding. Word to vec is one example of embedding. What is the embedding do? This embedding layer, this is the embedding layer, isn't it? If you give it as an input, if you give an input of word file, let me say embedding layer, that's what I'm saying. Embedding layer is like a word to vec. If you give input of word file, let me say there is a word file. What input will you give to this embedding layer? I'm giving word file. What will it do? It will return. It will return. What will it returns me a vector, isn't it? In similar manner, that's what it does. If you give, let me say word 1, it will give me a vector representation of word 1. That is the purpose of embedding layer. Why are we doing all this embedding? You just you can use what to vec. What is it? Why are we doing all this embedding layer? You can just use word to vec, isn't it? Why can't we use just word to vec? The reason being, this embedding layer can be trained as a part of your task, isn't it? If you use embedding layer, it can be trained as a part of your task. See, if you use word to vec, what happens? If you use word to vec, for every word there is a static word to vec and I'm not learning it as a part of my task. That's important here, isn't it? You will get a start is if you use word to vec, for every word there is a static word to vec, and we are not learning as a part of task. That is very, very, very important. I have my input here. Just see, let me say I have my input here. I have an embedding layer. If you see this code, just see, this is embedding layer. I am creating embedding layer with input being the number of, just see, if you see the code, what is this code? I am creating embedding layer with input being the number of, what is this? Input being the number of top words. I have 5,000 words. Let me assume I have 5,000 top words. That's what we were assuming, isn't it? I have top 5,000 words. That's what this is the code which we are discussing from previous class. I want output. What is the output size? I want output of size 32. So how many parameters this is input size is 5,000 keywords, output size is 32. That's important, isn't it? So what is the question? The biggest question here is how many parameters do I have here? How many parameters do I have here between my input and embedded? That is important, isn't it? So my input can be a 5,000 dimensional vector representing each word, and my output is of size. What is the output size? Output is of size 32. 32, there are 32 activation units here. So the number of parameters that I have between input and embedding layer is 5,000 into 32, that is 160k, isn't it? What is this? What is just what does it mean? What is this 5,000? Input is 5,000 dimensional vector representing each word. Output is of size 32, which means I have 32 activation units here. So the number of parameters that I have between my input and embedded layer is 160k. This 5,000 into 32 equal to 160k. That's what it says. Just see, these are the number of parameters, 5,000 into 32, which is equal to 160k. So when I finally print model dot summary, just see, this model dot summary means it actually tells us how many parameters are there. That's what it says. How many parameters are there? If I print this one, what it says 16k parameters. That's what we are saying, and I strongly recommend that you understand how you derived this number. That is important, isn't it? How you derived this number. This, what is this 5,000? 5,000 is number of words. What is 32? 32 is output vector size, isn't it? I'm literally creating 32 dimensional vector output, and I have 160. How many parameters I have? 160k parameters. 60, isn't it? That's what it says. Just if you are observe this code, what happens? I have done embedding layer, that I have LSTM 100. What is this model dot LSTM 100 means? Just observe, LSTM 100 means I have 100 LSTMs, isn't it? Each of these 100 LSTMs take, just see, each of these 100 LSTMs takes this 32 dimensional vector. Just see, all these LSTMs cells will take 32 dimensional vector, goes to each of these LSTM cells. Each of these LSTM cells generates output. So literally I have 100 units parallelly. I have 100 LSTM cells, one behind the other. Each of these cells, how these cells look like, just see, each of these cells, just let me show that this is 32 dimensional vectors go to each of these LSTM cells, and each of these LSTM cells generates output, isn't it? What it says, each of these cells, what is this? This 32 dimensional vector input, isn't it? It generates output, and it generates outputs, and also it has got some feedback loop, isn't it? Because you are going to send first word, you are going to send first word, second word, third word, fourth word, so on and so forth. I am sending first word, second word, third word, fourth word, so on so on and so forth. This is what an LSTM 100 means, isn't it? Let's understand how many parameters are there. As I told you, you understand these number of parameters will give, understanding number of parameters will give lot of clarity. So there is a very nice question answer blog, stock exchange, which explains how many activation units are there in LSTM layer, and the formula. There is a formula for this one. If you have an LSTM layer, let's look at whole. Just see, let's look at this as one layer. Let me assume this is one layer. How many inputs does it have? I have 32 inputs and it has 100 outputs, because it has 100 LSTMs. Each of them goes to, what is this? Each of them just going to send me one scalar value. Each LSTM cell is going to send one scalar value. This output vector that I get here is of size 100, isn't it? The output vector I will get is size 100. I have 100 outputs, and the number of parameters in LSTM layer, 32 inputs, 100 outputs. I have, just observe this one, I have m inputs. What is the number of inputs? I have m inputs and n outputs. The number of parameters is 4 into nm plus n square plus n. This plus n, just see, this plus n occurs if I have a bias term. For every weight, there is a corresponding bias. LSTM in Keras, for every weight there is corresponding a bias. LSTM in Keras by default have biases. If you don't have bias term, remember, just see W transpose. If you recall what happens here, if you don't have bias term, remember what is bias term in W transpose X plus B. This plus B, this B is your bias term. If you don't have bias term, you have this plus n. Otherwise, if you have bias term, you have this plus n. Otherwise, if you don't have bias term, otherwise, what is your formula? 4 into nm plus n square. By default, LSTM kernels has bias term, isn't it? Let's just insert these values into formula exact. Where can I find this formula? This is reference link, datascience.stockexchange.com, isn't it? Exact derivation of this formula is actually not very hard. I recommend you to read this question answer section, question answers blog, where this particular formula 4 into nm plus n square plus n is explained. Just what am I doing here? Just I am substituting. Let me assume m equal to 32 and n equal to 100. The number of parameters, if I substitute, what will I get? And I will get 53,200. And what is n value 32, n value, let me say 100. What you see here, so understanding the number of parameters is very important. This 53,200. Now let's look at the next layer. Just see, understanding the number of parameters. Understanding the number of parameters is very important. Now let's look at the next layer. What is this next layer? So I have my embedding layer. I have my LSTM, and I am connecting to dense output. LSTM underscore 1 LSTM. This is, just see, what is this? Model.add dense 1 comma activation equal to sigmoid, isn't it? What is the meaning of 1? 1 means one activation unit, and it's sigmoid activation unit. I am taking all these outputs and connecting to sigmoid. It is sigmoid activation unit, and I am taking, what I am doing here, just understand this one, all these outputs. Just I am taking all these outputs and connecting to single sigmoid to generate my yi cap, isn't it? I will repeat. I am taking all these outputs. I am taking all the outputs from LSTM cells and connecting to a sigmoid to generate my yi cap. Remember, yi cap is binary. I am taking all these 100 inputs and one bias term. 100 inputs and one bias term. This is this B is nothing but bias term. What is this? This is sigma of W transpose X plus B, where sigma is simple sigmoid function. How many weights are here? You have 100 weights. That is important. How many weights you have here? You have 100 weights corresponding to each of these inputs, and you have one bias term. You have one bias term, so you have 101 parameters. How many parameters you have here? 101. So if you sum up all of them, just see, if you 101 plus 53,200 plus 16,000, if you sum up all of them, you will get 213,301 parameters. I am saying my loss is, just see, what is my loss? My loss, just observe this particular code. My loss is binary cross, what is this? Binary cross entropy. And my optimizer, what is this? My optimizer is Adam, and my matrix is accuracy. Very, very simple, nothing very fancy. I print, just see, I print model dot summary, model dot this, just say model dot fit. What is this model dot fit? Here you have batch size. What is the batch size? You have batch size 64. We are using 10 epochs, and I am going to evaluate the model on my test data at I am going to evaluate the model on my test data. At the end, I am going to print accuracy, isn't it? I am going to print accuracy. Just see here, score equal to model dot evaluate, isn't it? What is this? I'm on my, what I am doing? I'm just see this one, what it says, model dot evaluate. Model dot evaluate means what? I am going to evaluate the model on my test data. At the end, I am going to print. I am going to, this is evaluating the model on my test data. At the end, I am printing accuracy. Accuracy, just if you see accuracy at epoch 1, just say how many epochs I am running. At accuracy at epoch 1 is 0.78, epoch 2 is 0.8434. Something went wrong in epoch 3, epoch 3, that's why it's reducing accuracy. Again at epoch 4, 0.8, so on and so forth. You will repeat it for 10 epochs, isn't it? Ultimately at 7th epoch it is giving 0.926 accuracy. The most important takeaway in these videos from my previous in this particular code example on embedded Imdb sentiment classification is padding. Why do we need to use padding, isn't it? Padding is very important lesson here, and how batch LSTMs work. That's the first key lesson. Second key lesson is embedding layer, and most importantly the whole architecture. What does LSTM 100 means? Each LSTM cell might learn different things, isn't it? Just I request you to go through this lecture once or twice. If you have any difficulty, please keep a comment. Thank you very much.